Okay, this is the part 2 video that goes with the lecture over your assignment number 9. It covers topic 6.3 and 6.4. 6.3 was learning multiplying polynomials. This video is going over the dividing polynomials. So if you notice, when we're dividing by a single term, which is called a monomial, what we're going to do is write the division as separate fractions. So because there's one single term down here, we're going to write this as separate fractions because that 2x squared actually goes to each individual term up top. It's just visually, it looks like you only see it once, but it really goes to each of those things separately above it. So I'm kind of writing that as I talk. If you need to pause to do the same, please do that. Once we do that, then we're going to simplify each fraction separately. So remember, when you have fractions from that assignment number 9 lecture, you will be subtracting exponent and leaving it where the larger exponent is for the variable part. Now, the coefficient part, the numbers that are in front of those variables, remember, they can just be reduced like a normal fraction, like you would, okay? So 4 divided by 2 is 2. So since it divides up into that, that's going to stay on the top part. And I'm saying that because I noticed before I circled it that I had x squared in the bottom, so that's a bigger exponent than the x in the top. So remember, when we subtract our exponents for our variables, we leave it wherever the larger exponent was. So 2 minus 1 leaves us with x in the denominator, and the y's would zero out. Okay, so plus 2 goes into 8 4 whole times. My x squareds are the same, so they zero out, and my larger exponent for y is also in the top. So 2 minus 1 is just y to the understood 1. Now, I would not need to, it's not necessary to put that over 1 since nothing stayed in the denominator. I can't reduce 5 over 2. I would never ever turn that into a decimal. We're leaving that as a fraction, okay? And then we can reduce the variable part. So 3 minus 2 is 1, so x to the understood 1 stays in the top. And my y's are the same, so they zero out. So you're not going to always get nice, pretty looking answers. You may have fractions in your answers when you're dividing these terms, but you need to do each one separately and see what each term ends up being after you reduce it separately by that 2x squared y. So doing another one like that, I have 21x to the 5th, y squared z to the 7th. It gets put over your 7xyz plus, because there's a plus sign between them up there, 49xy to the 4th, z to the 9th over 7xyz. Okay, so now we're just doing the same thing. We're going to simplify each fraction separately just to see how that would reduce. Okay, 7 goes into 21 3 times, and what I notice is all the exponents are bigger on the top, so it's like it's dividing it all up into the top of that, so you won't have anything left in the denominator. So for x, 5 minus 1 is x to the 4th. For y, 2 minus 1 is y to the understood 1, so I'm not going to put that understood 1. And for z, 7 minus 1 is 6. And then we have 49 divided by 7 is 7. Our x's would zero out. Our y, we're taking 4 minus 1 is 3, so that would be y to the 3rd. And for z, we're taking 9 minus an understood 1, which is 8. So again, it all divided up into the top, so this would be our answer for number, for example, 28. Okay, the next part of this lecture, we're talking about dividing using synthetic division. So you're going to be doing that when you're dividing by more than one term, basically a binomial. And so we can't set these up as separate fractions and reduce them like we do when we're dividing by a single term. So one thing that we're going to talk about is before you can divide, both polynomials should be arranged so that their terms are in descending order by degree. Make sure you fill in any missing terms so that they align properly. So sometimes what can happen is you have a missing term. So for example, x to the third plus 2x plus 3 divided by x plus 1. Okay, so sometimes you could have that. And so notice we are in descending order, but what's happening is we went straight from 3 down to x to the understood 1 power. So this is missing an x squared term. So when we're missing an x or a term for that matter, whichever one it might be, we're going to put a 0 in front of it, because when we're using synthetic division, we'll be working with the numbers in front of the variables and the constant. We're not really working with the variables. In this case, there's an understood 1 in front of that x cubed, so we would have to remember that too. So really what we have here is 1x cubed plus a 0x squared, because that was missing, plus 2x plus 3 divided by x plus 1. And so what we're going to be doing is working with the 1, the 0, the 2, the 3 in our dividing. So there is actually a long division way of doing this, which I'm not teaching you how to do it that way. It's very complex. It takes a lot of time. And so what you're learning is an easier way to divide these polynomials using what's called synthetic division. If you ever see an instruction that says divide by long division, you can just do this method. So I'm going to go ahead and just start working on that to show you what that looks like. So looking at 29, notice that we do have our exponents counting down to 1 and none. And we have a x plus 2 over here. So we have to remember that there's an understood 1 in front of that x squared. So I'm going to use that 1, going to leave a space, 4, leave a space, and 3. Then we're going to do an upside down division hat looking thing. And over here, we're going to look at this other parentheses, and we're going to always use the opposite sign of whatever is, whatever that number is. In this case, right now, it's a positive 2. So I'm going to use a negative 2 over here. So what we'll do is bring down this first number, number 1, and then we're actually not dividing at all. We're multiplying and then adding or subtracting in this method. So negative 2 times 1 is a negative 2, and then we're going to add or subtract these. Since they're opposite signs, we're subtracting. So 4 minus 2 is 2. Negative 2 times 2 is a negative 4. Okay, so you would multiply down here like we just did, bring it here, combine. Negative 2 times 2 is negative 4, and then combine. 3 minus 4 is negative 1. Since there's not another column, we stop. So that last column is often going to be what you think of as a remainder. Okay, and we'll be doing something with that. And then we need to go put our x's back in after we've done those processes. So if when you started with an x squared, when you plug this back in, you're going to plug in 1 less. So 1 less than x squared would be like x, right? X to the understood 1. So that's going to be 1 less of whatever that was. If this was x cubed, you would have started with x squared down here. Since this is a positive 2, we need to put a plus sign between it. And then because this is the remainder area, we need to put that over what you would have been dividing by. So x plus 2. So I know that looks kind of funky. It looks kind of like a weird answer. So what we need to do is clean that up. I'll show you what that looks like. So we wouldn't want to put the understood 1 in front of that x when we're typing that into WebAssign. So we'd have x plus 2 minus, and we have 1 over x plus 2. So that was a negative 1, but that was the sign separating those terms. Okay, this next example on the next page, it looks like a fraction, but it could be written divided by x plus 2 like we saw on the previous example, or what you see below. It's just another way to show that synthetic or that division, but this time it's by a binomial. So that's how we would know if we didn't say divide using synthetic division that we need to do that. That's what makes it different from the dividing monomials by one single term. There's more than one term down there. So we need to be sure that every exponent is represented and we're not missing something, which we are. We have 3, 2, and we don't have a 1. So it's like a 0x that's missing, right? Minus 6. So you could rewrite that x cubed plus 4x squared plus a 0x minus 6 divided by that x plus 2. You could write it out like that or put it back into the fraction. I just like to show the whole polynomial so that you can see each term. Remember, there's an understood 1 right here. So we're working with the coefficients, so that's really important. You have to have this 0x in there, otherwise your synthetic division isn't going to work, because this is kind of like a placeholder value. It helps keep everything lined up in order of those exponents, 3, 2, 1, and none. So we're going to use a 1, a 4, a 0, and a -6, and then our upside down division hat. Remember, we're using the opposite sign of whatever number's over here. So since that's a +2, I'm using a -2. And we would just always start with bringing that first digit straight down. Then we start our multiplication. -2 times 1 is a -2. 4 minus 2 is a +2. You can go ahead and put a plus sign in front of that because you're going to have to anyways, but I usually wait until I put my variables back in. Then we multiply again. -2 times 2 is a -4. 0 minus 4 is -4. Multiply again. -2 times -4 is a +8. So -6 plus 8 is a +2. So remember, this column right here, the very last one, is representing a remainder. We're going to go put our exponents, our variables back in, starting with 1 less than the exponent you see from the original problem. So since it was x cubed, I'm starting with x squared when I put them back in. And so I need to put a plus sign since that's a +2 and an x. So you're counting down to 1 and none. And then since that's a +2, I need to put a plus sign. And remember, we're putting that back over what we divide by. So if you clean that up, the way you would write that in WebAssign is you wouldn't put the understood 1 in front of the x squared plus your 2x minus your 4 plus that term of 2 over x plus 2. Okay, so let's look at the next example. Again, we need to make sure that every exponent is represented, counting down from 4. I notice I don't have a x to the third, so I'm just going to put it right there. You can rewrite the whole thing. I'm not going to this time because I can already kind of see my my order. One thing I want to point out, I haven't said it yet, but if there's a minus sign like over here, when you bring it down, make sure you keep that negative with it. I'm just making it a negative number. So we have 3, and then the 0, and then a -8, a +2, and a 1. And then we'll do our upside down division hat. Since this is a +2, I feel like we've been working with x plus 2 a lot. It's not always like that, but so since that's a +2, we use a -2. So again, to start this problem out, we just bring that 3 straight down. And we'll take -2 times 3 is a -6. And 0 minus 6 is -6. And then start over. -2 times -6 is a +12. And then combine -8 and 12, make a +4. -2 times 4 is -8. And then we're combining. 2 minus 8 is -6. And -2 times -6 is a +12. And 1 plus 12 is 13. Remembering that this is the remainder again, always at the end. Sometimes that remainder will zero out. But we're going to go put our variables back in. Since our starting exponent, our biggest exponent was x to the 4th, we're going to start with 1 less when we put our variables back in. So x to the 3rd, and then count down x squared. Since that's a positive, we need to put a plus sign back in. X and minus our constant. This makes our remainder. When we make a remainder, since it's positive, I do need to put a plus sign, but I just put it back over that binomial of x plus 2. If you were going through long division, that's what we would have been dividing by that x plus 2. So cleaning that up, it looks like 3x cubed minus 6x squared plus 4x minus 6 plus that 13 over x plus 2 as your answer. So we just have two more. Hopefully you're picking up on it the more we do it. It does kind of look like a magic trick, especially if you've ever seen long division. Long division is a lot of steps. You have to divide, multiply, change signs to add or subtract, and then start over. Divide, multiply, subtract. But this method is very quick and works every time. You just have to be very diligent about making sure if there's a missing term that you put a 0 in, otherwise you can make a mistake in that. You have to put your missing terms even in long division as well, but this is really fast method compared to long division. So this one does count down to 1 and none. So I have 7, I have a 37, and I have a 36. And then I call this an upside down division hat. And since that is a positive 4, I'm going to use a negative 4 over here this time. So what we're going to do is bring down that first term. This time it's a 7. So we'll say negative 4 times 7 is a negative 28. 37 minus 28 is a positive 9. Negative 4 times 9 is a negative 36. So this remainder column zeroed out. So we don't actually have a remainder in this one example. So I did kind of mention that you don't always have a remainder. A lot of times you do, but you don't always. So since our exponent started with x squared, we would start with 1 less, which is just x. So we have 7x plus 9. So that's all your answer is on that one, 7x plus 9. It was pretty short, just because on this one there were only 3 terms and we didn't have a remainder. The last one, we have a missing term of x, right? So I'll just put that right here, 0x. So we have a 3, a 0, and a negative 5. We're turning our division hat upside down, putting it under it. So since this is a negative one, remember we're using the opposite sign. So far it's always been like a +2 or a +4, and so we've used a negative over here. So since it's a negative one, we'd use a positive one. Okay, so be careful of that. You're using the opposite sign. You don't have to put that plus sign there, but I just did to kind of emphasize that I'm using a positive one. So we're going to go ahead and bring that 3 down. So we have 1 times 3 is 3, and then combine 0 plus 3 is just 3, and 1 times 3 is 3 again. And so we have negative 5 plus 3 is a negative 2. So what we're going to do is go ahead and bring our variables, or put our variables back in. Since our biggest was x squared, we need to bring just an x down to start with, right? Because it's 1 less. X to the first is 1 less than x squared. And so since that's a positive 3, we'd put +3. So that's going to be our constant. And our last column represents the remainder. So we would put it back over the binomial you would have been dividing by. So cleaning this up, it looks like x plus 3, or 3x plus 3 minus 2 over x minus 1.